Okay, let's go ahead and talk about section 4-3 today. Last time we talked about the side postulate and the side angle side postulate. And before that, we talked about proving triangles congruent. And the first time we talked about having to prove 6 congruences. Then in the last lesson, section 4-2, we only had to prove 3 of them. Either 3 pairs of congruent sides or 2 sides and the angle that they share. Well, we're going to step that up a little bit further when we talk about angle side angle and angle side. Now, as far as the homework quiz or as the practice problems, we've already done them before, and I went over in the previous statement in the previous video, so I just went ahead and posted how they work. You can look at them up on Saul's version when you do. All right. Now, I've also included postulate 4-2 and postulate 4-1 as well. They're simply just known as side, and side angle side. That's all you need to know. If you put those letters, you're good. You don't have to state postulate 4-1, side postulate. You don't have to write all that. Just write SSS. All right. Now, the third word we're talking about is the angle side angle postulate, which says if you have 2 angles and the included side of one triangle are congruent to 2 angles in the included side of the second triangle, then the 2 triangles are going to be congruent to one another. So here's what we have. We have 2 pairs of congruent angles, and actually that's not supposed to be there, so Anyway, just pretend like that one doesn't exist. So, all right, we'll just leave it at that. And the side that they share in common. Then you can prove triangle congruence, and that is by angle, side, angle. Angle, side, angle. All right. Now, let's talk about proving. It says that QS bisects angle PQR and angle PSQ is congruent to angle RSQ. So I'm going to write that there. Okay, and remember, I'm trying to prove that triangle PQS, which is the triangle in yellow, and triangle RQS, they are congruent. And there's supposed to be a congruent symbol in between there, so I'll just kind of throw that in there in the middle. And that is my given. Okay, now I'm going to mark that angle PSQ, which is this angle right there, is congruent to angle RSQ, which is right there. Okay, now it says that angle or QS bisects angle PQR. So when we say bisect, it means it splits it into 2 congruent angles. So that means that angle P, and actually I'm going to label this one angle 1 and label that angle 2. So angle 1, I can do that, by the way. As long as you label it in the diagram, you're good. So angle 1 is congruent to angle 2, and that is by definition of bisect. So it's by definition of bisect. All right, now, if you look, the yellow triangle and the blue triangle share something in common. They share SQ. So SQ is congruent to SQ, and that is by reflexive. So finally, I have enough to prove triangle congruence, and that is the fact that triangle PQS is congruent to triangle RQS, and that is by the angle side angle congruence postulate. And you don't have to worry about saying the angle side and just say ASA, and you're good to go. You are good to go after that. All right. Now, the next one we're going to talk about is the angle-angle side theorem. It is a theorem because it can be proven. And the difference between it and the other one is, and I'll show you in just a moment, I'll show you with the diagrams. Okay, angle, side, angle, two angles and a non-included side. Two angles and a non-included side, the two triangles are congruent. So here's what we have. We have two angles and a side that they don't include. Now here's the difference. Notice, two angles and a side they don't include, that is angle, angle, side, angle, side, angle. Two angles and a side that they do include. So this is ASA, that's AAS. I'm going to pause this for just a second. Okay, the next thing I want to talk to you about real quick, I'm just going to throw this in. We know that angle, side, angle, and angle, angle, side work. But what about side, side, angle? Does it work? And the answer is no. Here's why. Two pairs of congruent sides and an angle they don't share. Well, this is kind of a rough drawing. It's not accurate, but here you have an acute angle, and here you have an obtuse angle. So it's not going to work. And I always throw in a little hint. If it spells a bad word, it's not going to work. That's just a little joke inside if you look at this backwards. Yeah. So anyway, so angle, angle, side, or side, side, angle does not work. Just make sure you note that. All right. Now, we got a couple more proofs, so let's go ahead and let's do that real quick. And I'm going to pause it while I write down the given. All right. I went ahead and stated the given. I also highlighted the yellow and blue triangle so you know what we're trying to prove, in case I forgot later. All right. Now, here's a couple things you need to know. First of all, we can actually prove this one several ways. Now, because they're standalone angles, I can go ahead and just simply say that angle R is congruent to angle T, and that is by the fact that they are alternate interior angles. Remember, these two lines are parallel, so they are congruent. I can also state that angle Q is congruent to angle S, also by alternate interior angles. And we already know that they both share segment R. They both have RQ is congruent to ST. So I have enough to prove congruence. So therefore, triangle RUQ is congruent to triangle TUS, and that is by angle, side, angle. You can look at angle, side, angle. All right, now, we're doing really good on time, and we're almost done. Okay, I did the same thing here for the following. I did the same thing where I went ahead and worked it out and wrote out the... Okay, I want to show you one thing real quick. First of all, I know that BD is congruent. I know that BD and AD, they're perpendicular. That's what the symbol right here means, perpendicular. That means that they form a right angle. So there's a couple steps to that. I'm going to go over that with you in just a minute. And BD bisects AC. So let's start with that first. Okay, so AD is congruent to DC, and that is by definition of bisect. And that's already marked for us. Well, we also know that yellow and blue make green, so that means that BD is congruent to BD, and that is by reflexive. And then, now here's the next part. I'm going to call this angle 1, and I'm going to call that angle 2. Now, we know it's perpendicular, so we know that they're going to be right angles. And then we can come back and say that they're congruent. It's a couple-step process, and I'm going to go over that with you here. And I forgot to mark that these two are congruent, so let me do that. All right, so here's what I know. I know that the measure of angle 1 equals the measure of angle 2, which equals 90 degrees. And that is by the
Michael Richardson, please come to the front foyer.
definition
Michael Richardson, please come to the front foyer.
Perpendicular. It's a two-step process. You have to know this. If you know that they're perpendicular, you first state that their measures are 90 degrees. Then you can come back afterwards and say angle 1 is congruent to angle 2. And the reason is all right angles are congruent. All right. So now that we've stated that those angles are congruent, we can state that the two triangles are congruent by side angle side. So triangle, and I'm going to skip an open space. Triangle ABD is congruent to triangle CBD, and that is by the side angle side. Side, angle, and side. Two sides and the angle that they share in common. All right. Now that was section 4.3. We will spend some time on those sections in class. I'm going to go over some stuff with you extensively in class. So this is just a preview. This is what you need to know. And good luck on the homework quiz.